Hi, thank you. So hi, everybody. My name is Henri, or Henri in French, and I'm the co-founder at OK Contract, where we basically try to redo the front-end stack differently for crypto. So the talk today is a path to decentralized front-ends, and we'll see basically why we want decentralized front ends. Like we've been preaching in the desert for a couple years, telling people, oh, you know, it's very important to fully decentralize front ends. But now there's some help coming in. And that help is, for instance, the MiCA regulation in Europe, which, let's say, puts a strong incentive for DeFi projects, especially, to properly decentralize their front end, because they don't want to bear responsibility, and to do this, they must, let's say, prove that they are decentralized. And if you look at some of the articles that many people are publishing, there's a lot of, let's say, discussion about what it means being fully decentralized, because the law has this kind of meaning. So if you look today at what many projects do, like DCxPrague or Liquidity, they use ETH-Limo, which is basically a way to properly support ENS, to IPNS, to IPFS redirection for browsers that don't support it, because hopefully one day we will have native ENS resolution in all browsers, and if we do so, then of course that will be even easier to do the whole path. So in the end, we have decentralized storage, and we have a website which loads from decentralized storage. But the question is, what do we put exactly on IPFS? So what we put on IPFS is mostly the build artifacts. So you have your whole front-end code base, which is usually a complete mess of libraries and NPM dependencies. A bit more about this later. And somehow you manage to build it successfully and repeatedly with reliability. And you say, okay, this is what I'm putting on IPFS, and now my protocol has a decentralized front end. And we've seen a lot of projects mentioning this that way. However, if we just open the source code of the page, this is an example with for DCxPrague on ETH-Limo. And basically, we see very quickly in the code here in the middle, there's app.dcex.io, and which is, of course, an API, kind of looks centralized. And in fact, we had some discussions. So we asked some lawyers, they have different advice, and we asked the best lawyers of all. No, I'm sorry, it's just a joke. So obviously, even ChatGPT is aware that probably if you have a single API endpoint mentioned in your decentralized storage, somehow a judge will say that it's not really decentralized. And there's, I would say, one very simple litmus test. And that litmus test is basically if we somehow shut down or configure the network to block that centralized API, is the decentralized website still working? And of course, the answer is no. The dApps don't load if you shut them from that API. I'm not a lawyer myself, obviously, but everybody has their own conclusion. So when you're a project, you, let's say, have 3 GitHub repos, you have your contracts, you deploy them on EVM chains, you have your front end, and basically your build artifacts go to IPFS, and you have your API, which is usually AWS or GCP. So basically, is it decentralized? The contracts, yes. The front end storage, yes. But the API is not. So we say, we're looking for solutions. We're builders here, and we say, what's the best solution we can do? And we heard several times the idea of making a decentralized community of nodes of VMs, run by different people, different administrators. And all of these APIs would be quite diverse. And they would form somehow a decentralized set of API nodes for each of the projects. The problem is, of course, this is an ops nightmare because the stack is completely heterogeneous. There could be some Node.js, could be some Go, some Rust. And each VM instance should be maintained maybe by a different operator. So there would be guidelines, like a GitHub repo of guidelines on how to set up, maybe a repository of scripts, of Docker files. And the problem is that there's a lot of maintenance usually coming in to these nodes. So we thought that there could be one path, and definitely it's not the only path. It's just a path to rethink how we do the current implementation of front ends of a common, let's say, decentralized node protocol. And to do this, first I'm going to start with some bad news. The bad news is we won't be able to reuse the existing front ends. There probably are ways to do it, but working on a more generic solution means that we need to standardize the build to decentralize the run, but doing so, we change the build. And it gets back to when I started OK Contract. Basically, it was we started with one problem, is the lack of precise semantics for frontends. And if you look, for instance, at one, I would say, state-of-the-art front-end implementation, and of course, it's so state-of-the-art that now they even want to introduce fees for it. Basically, we look at just one page, add liquidity. And add liquidity is, just cutting the story short, 500 lines of code for just this single page. And those 500 lines rely on a very huge amount of components and libraries. So you'll see here you have a custom, of course, analytics package. There's React, there's Web3 there's Ethers as well, both of them. And Web3 React, there's a lot of dependencies. And then we have a lot and lots and lots of components and hooks. We see, for instance, to calculate slippage, to calculate margins, to list the different contracts that we are interacting with, etc., etc. And if we are concerned of extracting the actual semantics and extracting what is that we are going to compute on that client to perform the transaction on user behalf, we have to go deeper and deeper in different set of rules, which are usually interlined. So there's the components, and that code, again, is very well structured. It's one of the best implementation that we can find. A lot of definitions on the getting the state, of getting the transaction values, the formatted, compute the formatted amount, compute the max amount, etc., etc. And the lines go and go and go. And we still have basically the semantics of it, which is spread over these lines of code. And it's only at the function on add, which basically implementation begins like 200, that we are able to, let's say, send the transaction that we have computed and catching it. So why this? Because it's very complex, and our mission is how we can make it simpler. And knowing that there's a lot of things that we should compute on the clients. We should compute wallet changes, react to wallet changes, chain changes, be able to customize the interaction for the connected wallet, the balances, etc. And sometimes it's also more than one TX. In that code, we see a lot of glue required to manage the approvals, and sometimes on other projects, there's a series of operations that you want to do, like migrate liquidity from one pool to another. And coming next, of course, will be interaction with the 4337 bundlers, which will change a lot the interactions. And right now, most of the bundles for 4337s still have one TX. and or call multi-code. So there's a lot of things that we can do better here, but the front-end code is so complex already that it's hard to add them. And sometimes also, and maybe even beyond DeFi, but for DeFi as well, we need more than on-chain data. There's this off-chain data, for instance, NFT marketplace who have off-chain order books or data-intensive operation that you cache on these API nodes. And all this needs to be put together. So the solution that we began to think of was how to solve build and run by changing the build. So the build is first introduce a standard way to specify the smart contracts interaction semantics, which we think is lacking, and then an SDK to easily insert these transactions into any web page, dApps, without touching again that semantics. And for the run, then since we are making, let's say, a new clean sheet implementation of the front-end stack, then we can think of decentralized nodes and make everything so that the SDK automatically uses a decentralized node protocol. So to specify the interactions, we introduced, in fact, a purely functional language, which we call Lambda script, and which is kind of, let's say, a low-level intent of the transaction or a high-level definition of the transaction. And just to give you one example, so I could do add liquidity as well. It's on the next slide. I skipped it because it's just a bit more complex, but not too much. For instance, if you want to swap, basically you just need to say who you're swapping to, the tokens, what's the path that you need to send to the contract, functions in the standard library that helps compute the deadline. And we also need, for instance, to compute the amount out min, which involves RPC calls to the get amounts out function. And this is a proper Lambda script program, which we can just take, compile in advance into bytecode, being able to detect a lot of invalid specifications for the interaction, generating compile time errors in the middle. And then when we have this bytecode which represents, let's say, a seemingly valid transaction, then we have a TX transaction engine, which basically takes the user input and either gives a runtime error, this time on the right, or outputs the transaction. And so basically the runtime, the engine is a VM, which is based on the reactive programming, so that the whole definition, in fact, is a reactive program, and wallet events, on-chain events change the foundational data, and everything is recomputed automatically. And it automates two things, the RPC access, and as we'll see next, as well, the centralized API access. So now we are working on the SDK that we should release in 2023. That's pretty soon. Just after this talk, I will keep running code. No, I'm just joking. And so basically what we are building is, so we have a way to specify interactions using an ID, which is the hash of the interaction definition, basically, which you can as well visualize. So there will be a front end to visualize them. But most importantly, how it works, you just import new TX from the next OK contract SDK. And you say, OK, we want to do the transaction using that transaction ID. And for instance, we can set the value if we are swapping ETH to DAI here. So we just select the amount. And basically, from that point on, everything will be automated. So for instance, we can test that if we want to get the transaction from that high level specification, then for the connected wallet, it resolves to the estimated gas amount. It says that's the wallet which is sending the transaction to the contract. Here, I think it's SushiSwap on Girly, the value that we specified, etc. And all the parameters are built, and there's no errors. We also can generate some information which is readily available for instance, text or information bubbles or button names or everything that you can put as a developer into your UI without having nothing to do with computing the complex parameters, formatting the amounts that you'll get, etc. So you can show this the way you want to the end users. And from that point on, it's one line to just send the transaction. So we get a hash, and if we wait for the receipt, then we get a successful transaction, and that you can display and very easily. So it handles input detection, gas estimation, updates, including USD, error management, and support as well multi-step transaction, but that's beyond this talk. But getting back to the decentralized nodes part. So what we have right now is a way to properly define any kind of EVM interaction. So it could be DeFi swap. We have a Lambda script program, an ID for that. Staking some DeFi pools, adding liquidity or buying NFTs or accessing NFT utility or really anything because it's pure Turing complete, purely functional language. So we can specify any kind of transaction. And once we have this, we have the opportunity to run one common set of decentralized nodes for every of these specified transactions. So that's how it works, basically. The transaction engines is able to run any kind of program definition and connects to RPC and the backend API. And the only thing that we have to do, and that's kind of a joke only, is to decentralize the node themselves. So there are frameworks, so just adding the consensus and, of course, making sure that the definitions of new interactions are properly written is something that is already taken care of by multiple frameworks. But here there's a bit of issue in the way the nodes give trustful information to clients. And this is something that I will speak about a bit more on Saturday. But basically, we're building this set of backend APIs, which are decentralized. And I didn't say permissionless. So basically, it's because if you want to make these backend APIs permissionless, then there's another level. But decentralized is doable. And with the following goals. So the first goal is to be universal, and that's already tackled in the way we define the semantics for any kind of transaction. Another goal is to be performant and being cost-effective in terms of runtime. Ideally, there should be, let's say, in an order of magnitude, no more overhead compared to current RPC nodes, private nodes that you may use for any kind of project. And obviously, we want to be compliant with coming regulation for being a decentralized protocol and a decentralized interface. I think that in that area will be probably as fine as can be. The question we have is how to balance performance and security, because we can always be more secure, but it has a cost. And on the governance of the decentralized network as well. So there's a lot of things that we're thinking of, and if you have ideas or collaborations, happy to talk. And of course, the sustainability of the ecosystem. So how it should work, basically, for the sustainability is we will have a community of node operators who will get API access fees paid by project. There's one thing that we can do is we can make sure that an API key is only used for, let's say, a predetermined set of interactions, which is something that is not easy to do with RPC nodes. And also, we can build partnerships with MEV or Maeve sharing protocols, and maybe we can return one part of this to the users to be as fair as we can be, or we can share this with projects. And here, those are really questions, and I think there's a lot of discussion that we can have this week on that topics. So basically, that's one path where we can decentralize any front end. And as I said earlier, it's not the only path. Of course, there will be manually implemented front ends that everybody will try to run in a decentralized manner. And of course, it's, let's say, the closest way to do it compared to what exists today. But this is another path where we need to start anew with a definition which can be done, let's say, pretty quickly. And that will give a lot of benefits, like having another diverse implementation of front ends, which I think is of good value for protocol to resist censorship, for instance. And also that will come with the added benefits of being decentralized without too much effort, which I think is a pretty good value. So just to sum up a bit, the architectures that we discussed today will build front ends and store the artifacts on IPFS just as we do today to decentralize front ends properly. And that will give a user interface which includes the OK Contract SDK. And the OK Contract SDK manages automatically connection to the RPC node, to wallets, and to of course, the decentralized API nodes of the OK Contract protocol. So that will be the last slide, and how to contribute. There's several things that we can discuss as well. Is formalization. So right now we consider doing writing an EIP for the transaction specification, so mostly for the functional programming language Lambda script and the definitions of the standard libraries that we put in it. And I would say that's an opportunity for other protocols to be present, especially protocols that target front-end developers somehow. We probably can integrate and making your features available at first level. And that's something that we can contribute on. Another thing is, if you're a project, let's build interaction together for your protocol. And if people are running nodes for other protocols, of course, let's talk and be a launch partner for the node runners. So you can learn more. There's not yet too much public information, but on okcontract.com. And of course, thanks for following us on X now. It's at okcontract. And if you want to chat, I'm often responsive on X as well. I'm Henri _ OK. I changed my handle name a bit too late. So thanks a lot. And I hope that it was an entertaining way to begin the second day of DCxPrague. Thank you.
I have a few questions. The first one, we saw the example of the prepared or to be prepared transaction, right? Yeah. And you had there like the response texts mentioned there, right? Which would be like populating the UI. Do you treat there somehow localization and internationalization?
Yeah, so obviously we'll be able to localize in the future. So, but for now, the first version will be English only. But of course, yeah, it's international. II-18N is.
Do you think that would like change the architecture significantly when you go like 118?
I hope not. I worked on previous projects where we internationalized the front end, and that's peripheral. So this is an extra module, in fact, added to the rest of the core. So that should be easy.
And the second question is, we are talking here mainly about the web front ends, basically, right? Since you were researching this field, have you also researched the fact that many users are actually moving to the mobile apps, and how that could be applicable, or whatever there would be a way for the mobile apps, even though we know that due to the stores that there is some certain censorship or risk anyway. But is there any way for the mobile apps, like you presented for the web apps?
Okay, thanks for asking this question. So yes, the answer is definitely, and mobile was thought first before any kind of implementation. So of course there will be a mobile SDK coming in.
Cool, thanks.
Thank you. Any question?
It sounds like there are multiple things that you're packaging together that are probably useful independently, right? Like the setup that you have for decentralizing the API nodes seems relatively independent of what happens on the front end, right?
Yes, it's an added layer which benefits from the specification, because the way, in fact, we specify the interaction, make sure that we have common endpoints for any kind of interaction. So that's why basically it would be, I think, harder to adapt the decentralized nodes to the existing front end, unless all the front end, in fact, change a bit the way they are implemented today.
Yeah, thanks.
Do you address another point of centralization, which is access to IPFS, actually, like the gateway? Because most users do not run their own nodes, so they have to use this s.limo, and it's still point of centralization. That's the first question, and I have another one.
Okay, so very good question. And so no, right now we don't. There are several efforts in the Protocol Labs community in that regard, and we will build on whatever they're doing. And we already have enough problems on our own for now.
And second question, can Lambda be used for creating some kind of command line interfaces?
Oh, yes. And in fact, those tools do exist.
Okay.
And it started, so we started the core implementation with CLI.
Thank you.
Yeah, at the beginning I saw you had, like it would retrieve a widget with a code. Is that like a widget library? Is the intent that people will create widgets, put it on like a widget store, or?
Yeah, definitely. So one of the things, in fact, that we want to do as the let's say, okay, contract part brand somehow, and this is how we chose our name, is to give confidence in the interactions. So we will have a set of these whitelisted interactions, and which are part of the node protocol. So these interactions, in fact, are stored in the nodes.
Okay, that's all. Yep, thanks to everyone in the questions and for the talk.
Yeah, thanks everybody. See you.